Hi, my name is Brynne, and I'm an undergraduate student in the Faculty of Science. Welcome to the Manitoba Institute for Materials in Parking Lot A, surrounded by Parker, Allen, Wallace, and St. John's College. We've had lots of visitors wondering what's in this small building, so let's take a look. We're in the sub-basement, a floor below tunnel level and surrounded by several feet of concrete. This area, once home to a cyclotron, has been repurposed by MIM to host materials characterization instruments. The location is ideal for MIM as we are well isolated from external interferences that might disrupt data collection on the instrumentation. MIM hosts 5 main pieces of equipment: a transmission electron microscope, 2 scanning electron microscopes, an X-ray photoelectron spectrometer, and a small-angle X-ray scattering instrument. This instrument is MIM's FEI Talos TEM, or Transmission Electron Microscope. The former cyclotron space was ideal for this instrument, as we are shielded from external fields and vibrations. To probe a sample, the electrons pass through the sample and are collected on a 16-megapixel high-speed camera below. The beam is so fine that we can differentiate columns of atoms in a crystal of silicon. Our TEM is equipped with a quad X-ray detector, which is used for elemental characterization. In combination with our tomography sample holder, we can generate reconstructions of materials on the nanoscale, much like what is done with a CT or PET scan in the human body. MIM hosts 2 scanning electron microscopes, commonly referred to as an SEM. Like the TEM, we use a beam of electrons to probe the sample. The first SEM is a high-resolution instrument called the NOVA Nano SEM. This instrument uses an extramagnetic lens to create a fine spot of electrons, yielding a resolution of 1 nanometer. In addition to imaging, we can also look at the elements that make up the samples using X-ray spectroscopy, allowing us to see most of the elements in the periodic table. The second SEM, or Quanta, is an environmental SEM. The difference between this instrument and the other SEM is the ability to introduce an atmosphere of water vapor or gas. This allows us to look at non-conductive samples like insects or rocks or concrete and still obtain high-quality images of the materials. Here we have MIM's X-ray photoelectron spectrometer, or XPS. The XPS gives us information on the elements present in our materials with the added benefit of being able to learn about the bonding environment around an atom. Owing to the fact that XPS is a surface-sensitive technique, probing only the first few layers of a sample, it is particularly suited to look at thin films, such as those found on most modern sensors. With the addition of an ion gun to etch away the surface, XPS can be used to look at the composition of multi-layered materials, like transistors and fabricated electronic devices, where the layer thickness and interfaces play critical roles in device performance. Coupled with a charge neutralizer, the XPS can examine both insulating and conducting samples, making this technique applicable across the broad research interests of MIM members. The Manitoba Institute for Materials is a host to a variety of characterization techniques, allowing us to work with a large variety of materials, crossing fields from science and engineering to dentistry and agriculture. The collaborative nature of MIM encourages multidisciplinary study, bringing together members from across the U of M campuses. MIM also offers a materials characterization course, Chem 4802, ECE 4680, GL 4280, or GL 7790. Not only do the students get a theoretical understanding of these techniques, they also spend 4 weeks each on 3 of 11 total instruments. Talk to your academic advisor about enrollment and act quickly as spots are limited. Now that you know what happens inside this building, are you ready to step up to materials research?